Have you ever stopped to think about what's actually happening when your internet just dies? It feels like a total mystery, right? Well, today we're going to put on our detective hats. We are going to solve the case of the lost data packets. And in the process, we'll demystify network troubleshooting by cracking a real-world case step by simple step.
Oh yeah, we've all been there. You click on something, and you just get the spinning wheel of death. It's so frustrating. But behind that little loading symbol, there's a fascinating chain of events that is completely broken down, and we're going to investigate exactly what went wrong.
Okay, but before we can figure out what went wrong, we first have to understand what a perfect journey looks like. What's supposed to happen. So let's trace the path of a single data packet when everything is working just right. And here it is. This is our crime scene, or maybe better, our network wrap. The goal is super simple. We need to get a message, a packet, from computer PC1 all the way over to computer PC3. And those boxes in the middle, R1, R2, and R3, those are the routers. Think of them as the traffic cops who direct our little packet along the way.
So the journey begins. PC1 bundles up its message and sends it out the front door, which in the network world is its default gateway, router R1. You can think of R1 as the local post office for PC1's entire neighborhood. It's the first stop for any mail going out. Now, once R1 gets the packet, it looks at the destination address. It sees PC3. It then checks its internal rulebook. This is called a routing table, which tells it the best way to get there. And that rulebook says, hey, to get to PC3, you need to send this packet to the next stop, which is router R2. So off it goes. And when the packet arrives at R2, it's pretty much rinse and repeat. R2 grabs the packet, checks its own rulebook, sees the final destination is PC3, and knows the next stop on the line is router R3, so it forwards the packet right along. Simple enough. Finally, our little packet arrives at router R3. R3 looks at its rulebook and, aha, a breakthrough. It realizes that PC3 isn't somewhere else out on the internet. It's right here, on its own local network. So it delivers the packet directly to PC3. The message arrives and mission accomplished. Case closed. Well, at least when everything works. But what happens when it doesn't? Suddenly, our packet leaves PC1, full of hope, and it just never shows up at PC3. It vanishes into thin air. Now, the real investigation begins.
Now, any good detective starts with the usual suspects. Is it a bad cable? Did someone unplug something? Is the whole link just totally overloaded with traffic? Or, and this happens a lot, did someone just make a typo during the setup? Yep, simple human error is a huge culprit in these cases.
So, to narrow down our list of suspects, we need the right tools. We can't just guess. A network detective has a really powerful but simple set of commands they can use to gather clues and figure out what's really going on behind the scenes. And what's so cool about this is how simple these tools really are. Ping is basically like shouting into a cave, "Hello, are you there?" and just listening for a reply. Traceroute is like asking your GPS for step-by-step directions. And my favorite, show IP route. That's the master key. It's like walking up to a router and demanding, "Show me your rulebook," so you can check the instructions yourself.
All right, time to get our hands dirty. We have our map, we have our tools, and we have a missing packet. Let's start applying our techniques and find out where our data went wrong.
This is the one question we need to answer. Where is the connection actually breaking down? We know the packet isn't getting from PC1 to PC3, but is the problem at the first router, the second, the third? Let's find out. So first things first, we confirm the crime. We run a test from PC1 trying to reach PC3 and, sure enough, nothing. No response. Our packet is officially lost in the digital ether. Our mission is to figure out where and why. Okay, time to use our tools. We pull out our ping tool and test the connection from R1 to R2. And we get a reply. It's a success. Now this is a huge clue. It tells us the physical connection between the first two routers is working perfectly fine. So the problem has to be somewhere further down the line. Now, just to be thorough, we tried pinging from R1 all the way to R3. And wait a minute, that works too. That's kind of surprising, right? This tells us all the wires and basic connections between all the routers are okay. The road is clear. So if the road is clear, why isn't our traffic getting through? The plot definitely thickens. And now for the breakthrough. This is where we crack the case. We use our master key, the show IP route command on router R2 to look at its rulebook. And there it is, the smoking gun. Look at that highlighted line. R2 has a rule for traffic that's supposed to go back to PC1's network, but it's sending it the wrong way.
Instead of pointing back to R1, it's pointing it over to R3. It's like a road sign pointing you east to get to a westbound highway. No wonder our packets are getting lost.
And check this out. Here's the fix right in front of us. On the left, you see that bad rule, the one that sent our packet on a wild goose chase. And on the right, the correct rule. That's it. It just took one single line of configuration to tell R2 the right way to send packets back. And with that simple fix, poof, our connection is back up.
So the case of the lost packet is officially closed. But what's the big lesson here? What can we take away from this whole investigation to become better network detectives ourselves?
Here's the most important thing to remember. Troubleshooting isn't some kind of dark magic. It's not guesswork. It's a logical, step-by-step process of elimination. You don't just guess what's wrong. You systematically test the path, piece by piece, and then you check the rulebooks. It's a skill that literally anyone can understand. So let's boil it all down to a simple, 3-step process you can always remember. Number 1, verify. Ping to see if you can even talk to the devices. Number 2, trace. Trace the route to see the exact path your data is taking. And number 3, inspect. Inspect those rulebooks to make sure the directions are actually correct. Verify, trace, inspect. That's your game plan. And that really brings us to one final thought. Our entire modern world is built on millions, probably billions of these tiny little rules in these rulebooks. This whole mystery we just solved was caused by one single incorrect line of text. It really makes you wonder, doesn't it? What tiny little error could be hiding in the rulebook of the networks you use every single day?